Hey there, we are Team 15 here to present our final presentation for Big Data Analytics. The project title is Stock Price Prediction Based on Sentiment Analysis. Our team members are Balachandra, Swasti, and Vedavikashini. Coming to the goal of the project, the main objectives are to handle significantly large data and predicting the nature of the changing stocks, to effectively compare the different machine learning models by using ensemble learning, to see the nature of deep learning models used in short term and long term cases. Here, the choice of deep learning model is LSTM. And finally, to comparatively analyze their accuracies to glean an understanding of their performance. So as a part of this project, we mined two types of data. The first one is the Twitter data. For Twitter data, we made use of the TW Scrape, which is an open source library which scrapes relevant tweets according to the company. Here we fixated three companies, Google, Microsoft, and Amazon. The data is fetched using 25 API calls company-wise for each date by filtering out any links, media, and replies. And we can also see the word cloud for Google in this slide. Coming to the pre-processing step for these tweets, this involved the removal of hashtags, URLs, and strange symbols. This was followed by tokenization and stemming. And then the term frequency, inverse document frequency was computed. And finally, the sentiment marking was done using the Vader lexicon. The second data that was mined was the stock data, which was done using the Yahoo Finance API. As a part of this, we extracted the stock price and volume since 2021, that is for 3 years approximately, by selecting three companies, Google, Amazon, and Microsoft. The process walkthrough is that we extracted the data using the Yahoo Finance API. The data comprised of the open, high, low, volume, close, and adjusted closing price. The adjusted closing price is a better indicator than the closing price. It's a better predictor because it includes the dividends and stock splits in addition to the close price. And the final step for curating the data was asked for to add more indicators, and this was done using the technical analysis package from Python. So this was involved in adding more indicators like the momentum indicators, trend indicators, and volume indicators, and economic indicators and volatility measures. But however, the data that we obtained was of a very high dimension, and hence, as a solution, we employed the PCA, which stands for Principal Component Analysis. As a part of this, we diminished the large data set into 10 dimensions. Coming to the models part, we employed both machine learning models and a deep learning model. The three machine learning models which was employed are random forest, linear regression, and AdaBoost. Random forest was used because it is usually good in dealing with noisy data, which is very common for the finance data. Linear regression was primarily used as a baseline because we wanted to find a linear curve. The LSTM model is used because of its ability to train and learn the long-term interactions as well. Because in this project, we are aiming to also predict the closing price after a 14-day window in addition to the next day window.
Coming to the technologies used in this project, we used Vader for sentiment analysis from the Natural Language Toolkit. sklearn and TensorFlow modules are used for training the previous machine learning models and the one deep learning model, which is LSTM. And technical analysis package is used for mining the indicators such as the momentum indicator, volume indicator, and trend indicators, and for obtaining those 86 columns, which we combat using PCA. And TW Scrape is that open source library which we use for mining the tweets. The front end is visualized using HTML, CSS, JavaScript, and Streamlit. And since the code that we write is on a Jupyter notebook powered by a Dataproc cluster, we also use GCP for data collection. We primarily wanted to observe the effect of PCA in long-term and short-term prediction of adjusted closing price and see what kind of effects it has. So we have 4 experiments which are predicting the closing price for the next day without PCA, for predicting the closing price for the next day with PCA, and for predicting the closing price for a 14-day window without and with PCA. This is the system overview. So we undergo basic data pre-processing for the stock data from the Yahoo Finance data set, and then the technical analysis package is used to mine more indicators for it. The tweets data undergoes text pre-processing and then follows by tokenization, TF-IDF stemming, and Vader sentiment analysis from the Natural Language Toolkit. Finally, we attach a sentiment score, and this polarity is combined with the stock data. Then PCA is performed on it, and then the training begins with 3 machine learning models and the deep learning model. We also try to see if the validation metrics that we gain from the training match up to the inherent behaviors of all these classifiers and what we know about them. So as we can see from the results, Random Forest consistently performs well across scenarios and companies. It has a very good MSE and R-square score. Linear regression tends to have higher MSE values, but it still maintains reasonable predictive power. So as you can see, the MSE values are usually above 100, but the R-square values are pretty good. And AdaBoost shows balanced performance, but it is sensitive to the presence of PCA, which is precisely what we wanted to observe. As we can see in the Microsoft case, AdaBoost shows without PCA MSE as 60.97 and with PCA as 121.38. And LSTM definitely performs better with PCA with lower MSE for the next day than for the long-term case of 14-day window. If we have to see the effect of PCA company-wise, we can see that the most impact is on Microsoft and Amazon. As in Microsoft, PCA results in a higher MSE for all models and scenarios. The R-square scores are slightly lower with PCA. In Google, the impact of PCA is inconsistent, but again in Amazon, PCA tends to increase MSE and reduce R-square scores. And now we will see a demo video showing the front end.
We have seen the implementation of data scraping, data pre-processing, and various performance of various regression models. And now we need to combine everything in order to create a dashboard. We take the best performing model. In this case, like we will be like going with the LSTM model and create a dashboard using Streamlit. So Streamlit is open source Python library which enables developers to build user interfaces. For our project, it is advised to daily update the model and the dataset. The reason behind this will be discussed in detail in a couple of minutes. So, let me run the dashboard. Yeah, like it's running like just a couple of minutes. Yeah, we got it. Now we have selected for Microsoft. Let's select like a couple of years ago, August 13th, and let's give it today's date. Here we could here this is here in this dashboard. It contains all the necessary details, like this contains all the necessary values here. For example, the date, the opening price, the high price, low price, close, adjusted close, and volume for that particular date. And this is an interactive table. Here you could search for any particular day, say for example 2022, 22, and you're searching for a month of May. Yeah, we got it. Like we could find all the necessary uh, values for the month of May, like high value closing price and low and adjusted close. And moving on, here we could see the graph. The blue value is the actual value and the red is the predicted value. This is again, this is an interactive graph, and when we zoom into the values, say in this case, here we could see like the model as predicted correctly the closing price for this particular day, that is for day one, and the prediction has gone a little off for the next 7 days. Hence, because of this particular reason, it is highly recommended to train the model and acquire the dataset daily. And moving on, here we get the live Twitter trends, and we'll get a public perception about that particular stock. For Microsoft, today's sentiment is like for a sample of 20 to 30 tweets, almost 38 percentage of people have like positive opinion about the stock, and 41 percentage of people have like of the tweets have neutral sentiment about the stock, and only like 20 percentage have negative opinion about the stock. And you will be seeing some sample tweets. And yeah, like you can select like multiple various company, and yes, it's running. For Google, like let's see the updated values, say like 40 percentage is the positive sentiment and 45 percentage is the neutral sentiment. And let's for Amazon, it's yes. And for Amazon, for some reason, like for more than 50 percentage, 57 percentage of the tweets have like positive sentiment, and 33 percentage of tweets have like neutral sentiment, and only 9 to 10 percentage of tweets have like negative sentiment. Uh, so yeah, this is the interactive dashboard which we have created for our project. Thank you.